Hi, welcome to pibyme Maths. This is Devan. In this video, we'll be looking at May-June 2023 for the Pure Math 1 paper. Let's look at question number 1. Use the standard results for sigma r square and sigma r cube. Both of these results are given in the data booklet. To show that for all positive integers n, sigma r square times r plus 2 is this. So I'm going to take the sigma notation, the left hand side of the equation. Open the bracket, so open the bracket and split it, so we'll get sigma r cube plus 2 sigma r square. The limits are r is equal to 1 to n. Now we use the results from the data booklet. For n cube, the result is n square times n plus 1 whole square over 4. 2 times. For r square, the result is n times n plus 1 over 6 times n plus n times n plus 1 times 2n plus 1. So if you cancel this, it's going to be 3. We need 1 over 2 as a common factor. 1 over 12. So I'm going to take 1 over 12 as a common factor. To take 1 over 12, I'm going to multiply this by 3, this by 4. So I will get 12 in the denominator, right? And then I'm taking n times n plus 1 also as a common factor. So in the first term, if you have taken all this n times n plus 1 as a common factor, you'll be left with 3 n times n plus 1 plus. In the second term, if you have taken n times n plus 1 over 12 as a common factor, you'll be left with 4 times 2n plus 1. Now we just need to open the bracket and simplify, write it in this format. Okay, here copy the step here. You need to write it in this format. So 1 over 12 n times n plus 1. When you open the bracket, you will get 3n square plus 3n plus 8n is plus 11n plus 4. That's all. We got the answer already. It's a 4 mark question. Question number 2. Given that x is equal to 2 plus 3i is the root of this equation, write down another complex root. Whenever they ask you to find another complex root, take the complex conjugate of this. So x is equal to 2 minus 3i. Always remember, you need to change the sign of imaginary part. If it's given this way, the complex conjugate would be minus 3i minus 2. Don't write 3i plus 2, that's wrong. You need to change the sign of the imaginary part, not the real part. That's all, just a 1 mark question. Part B, use algebra to determine the other 2 roots of the equation. Okay, we have 2 roots already. 2 plus 3i, 2 minus 3i, right? Let's find the sum of the roots. When you add them, you will get 4. 3i will be cancelled. Product of the root. 2 plus 3i times 2 minus 3i. A plus b times a minus b. A square minus b square. We know I square is minus 1. So 4 plus 9 is 13. So we can write a quadratic function as x square minus sum of the roots times x plus the product of the roots. So what I have done here, this is going to be one of the factor of the given function. So we need to find another factor. So I'm going to take the function now. Okay, so I have taken the function and write it as equal to x square minus 4x plus 13. We got this quadratic factor by using the 2 roots here, right? And then there will be another quadratic factor, ax square plus bx plus c. How do I know it's going to be another quadratic factor, not a linear one? Because it is x power 4. So when you multiply these two, you will get x power 4. Now just find the values of a, b, c now by comparing the coefficient. If you know long division method, you can divide this function by using this divisor, or just use this method. Compare the coefficient of x power 4 on both sides of the equation. So 2 is equal to After opening the bracket, you'll get ax power 4. We got the value of a. Compare the coefficient of x cube on both sides of the equation. Minus 8 is equal to, here you will have bx cube minus 4ax cube, b minus 4a. So we know a is 2, sub in here, minus 8 goes to the other side, you'll get b as 0. And the easiest way to find c is, you can substitute some value in the place of x. I'm gonna sub in x is equal to 0. So all these terms become 0. 39 is equal to 13 times c. These two also 0. So c is equal to 3. So therefore the other factor is ax square plus bxb is 0 plus 3 is equal to 0. So when you equate it to 0, you will get the other two roots. So x square is equal to minus 3 over 2. X is equal to plus or minus square root of negative 1 is I root 3 over root 2. Part C now. Show all 4 roots on a single organ diagram. The roots are 2 plus or minus 3i plus or minus I root 3 over 2. So I'm gonna draw the organ diagram. This is imaginary axis, real axis. Always label the axis. Imaginary 1, O. And then 2 plus 3i. Let's say 2 is here, 3 is here. This is 2 plus 3i. And the reflection will be 2 minus 3i. If you want, you can join them using a line also. And then root of 3 over 2. I'm going to get the value of root of 3 over 2 first. That's 1.22. That tells us it's smaller than 2, so it should be here. Oh, okay, not here. It's the imaginary part, so it should be here. And here. So you can write it as I root 3 over root 2, or put it as a single root, minus I root 3 over 2. That's all. You can just put a little cross here. That's all. It's a 2-mark question. Let's look at question number 3 now. The rectangular hyperbola H has equation xy is equal to 9. The point P with coordinates 3t, 3 over t, where t is not equal to 0, that lies on H. Use calculus to find the equation of the normal at P. First, you need to differentiate the function. Write it as y is equal to 9 over x, or 9x power minus 1. dy over dx is minus 9x power minus 2, right? Now the slope of the tangent is, in this dy by dx, you need to sub in the x coordinate of the point. So minus 9 times, you can write it as minus 9 over x square. So minus 9 over t square, 3t square, minus 9 over 3t whole square. So 9 will be cancelled. You will get this. Since normal is the, I'm going to write it here. The slope of the normal will be, since normal is a perpendicular line to the tangent, you need to take the negative reciprocal of this, which is positive t square. So we have a slope, we have a point, we can write the equation straight away. Y minus y1, take this point as x1, y1. Slope times x minus x1. But we need to write it in this format. So multiply throughout by t to get rid of the fraction. Ty minus 3 is t cube times x minus 3t, which is t cube x minus 3t power 4. Bring t cube x this side, you'll get ty minus t cube x is equal to, bring 3 to the other side, 3 minus 3t power 4. On the right hand side, they want a function of t. That's all. It's a 4-mark question. Part B now. Given that t is equal to 2, determine the coordinates of the point where the normal meets h again. Okay. We know the equation of the normal. Ty minus t cube x is equal to 3 minus 3t power 4. You replace t by 2 here. So we'll get 2y minus 2 cube x is equal to 3 minus 3 times 2 power 4. You get minus 45. That's the equation of the normal when t is equal to 2. This normal, this line meets the curve. The equation of the curve is xy is equal to 9 at a point again. So you need to solve these two actually. So we can take y is equal to 9 over x and sub in here. 2y is 2 times 9 over x minus 8x plus 45 is 0. Multiply throughout by x, you will get 18 minus 8x square plus 45x is 0. Multiply throughout by negative 1, write it in the standard format. 8x square minus 45x minus 18 is equal to 0. Which is a quadratic equation. We can solve it. 8 minus 45 minus 18. 6 and minus 3 over 8. X is equal to 6. X is equal to minus 3 over 8. So you need to write this step, otherwise you will lose them all. 8x plus 3 is equal to 0. Okay, there are two values of x. Which one are you going to take? You see, in this point P, if you replace t by 2, you will get x coordinate 6. So the x coordinate 6 is the x coordinate of the point P. So you cannot take 6. You need to take this. And sub in here to find y. So when x is equal to minus 3 over 8, y is equal to 9 divided by minus 3 over 8. Which is going to be minus 24. So finally you need to write the point. They want you to find the coordinates of the point. So therefore write it as a point. Minus 3 over 8 comma minus 24 at the end. That's all. It's a 3-mark question. Question number 4. A matrix A is given. The transformation represented by A transforms a triangle T to T dash. It transforms a triangle T to T dash. The area of the triangle T dash is 3 times the area of the triangle T. Okay. If it transforms a triangle or any shape to another shape, if you take the area of the first shape times the area scale factor determinant of A, you will get the area of the transformed shape. So we need to find the determinant value of A, which is gonna be, when you multiply this, you will get minus 3k minus, when you multiply this, you will get minus 24, so plus 24. But we don't know whether k is positive or negative, and we don't even know the value of k. But the determinant value, when we take the area of the scale factor, we take it as positive. So you need to put a modulus sign here. Now t times the determinant value of A is equal to t dash. But the question clearly says the area of triangle T dash is 3 times the area of the triangle T. So you can write as 3t. T is the area of the triangle T. So when you cancel it, you will get modulus 24 minus 3k is equal to 3. So take the modulus, split the modulus into positive argument and negative argument. What does that mean? Remove the modulus and take it as positive 24 minus 3k is equal to 3. Negative 24 minus 3k is equal to 3. If you don't know what the modulus sign means, it will change everything to positive. So even if it's a negative number, it will change it to positive. That's why we use this modulus. You will learn more about this modulus function in Pure Math 3. So now you just need to consider both positive argument, we call it positive argument, and negative argument. So it can be a positive or negative number, right? And make k as a subject. Here you're going to get k is equal to 24 minus 3 is 21 over 3 is 7. Minus 24 plus 3k is 3. So k is 27 over 3, 9. So two possible values of k. Let's move on to next one, double I. B is given, BC is given. Determine in terms of A the matrix C. First I'm going to find B inverse. The determinant value of B is 3A minus this. So it's positive 8. You don't need to put a modulus because we are not talking about the area scale factor. We are talking about the determinant value of B. The determinant value can be a positive number, negative number, or 0 also. So leave it as it is. B inverse is, the formula is 1 over the determinant value of B. And then swap these two elements, 3A. Invert the sign of these two elements, minus 2, positive 4. That's how you find the inverse of a 2 by 2 matrix. Why we are finding B inverse? Because it's given BC is equal to 2, 5, 1, 1, 4, 2. They want us to find C. To find C, we are going to multiply both sides of the equation with B inverse. So when we add B inverse on the left hand side here, we'll add it on the left hand side here. So it's going to be B inverse BC is equal to, write the B inverse, 3A plus 8, keep it outside, 3, 4 minus 2A, and then this matrix, 2, 5, 1, 1, 4, 2. The B inverse, when it's multiplied by B, it will become identity matrix I. I times any matrix, you will get just the same matrix. C is equal to 1 over 3A plus 8 times these two matrices. Now we just need to use the matrix multiplication to find C in terms of A. So I have moved this here. I'm going to apply matrix multiplication by keeping this 1 over 3A plus 8 outside. Take the first row, multiply by first column, second column, and third column. You should have learned the matrix multiplication first. So 3 2s are 6 plus 4. 3 5s are 15 plus 16. 3 times 1, 4 times 2. And then take the second row and do the same thing. So you will get minus 4 plus A, minus 10 plus 4A, minus 2 plus 2A. Simplify 1 over 3A plus 8 times 10, 31, A minus 4, 4A minus 10, 2A minus 2, 11. You can leave it as it is. This is C. Or you can divide each element by 3A plus 8. Both are correct. You can write one more step if you want. 10 over 3A plus 8. A minus 4 over 3A plus 8. 31 over 3A plus 8. 4A minus 10 over 3A plus 8. 11 over 3A plus 8. 2A minus 2 over 3A plus 8. Question number 5. F of x equals 0 has root alpha and beta. Without solving, find the value of this. Okay. So sum of the roots alpha plus beta will be equal to minus b over a. A is the coefficient of x, b is the coefficient of x square, b is the coefficient of x, c is the constant term. So minus b over a will be, b has already a negative sign, positive 6 over 1 is 6. So it's just 6. Product of the roots would be c over a, 3 over 1. Now we need to find this. So when you open the bracket, take alpha square, multiply both, you will get alpha square, beta square plus alpha square. Take 1 and multiply both, plus beta square plus 1. So it's basically alpha beta whole square, the first term. The second term, if you take a plus b whole square, it's going to be a square plus b square plus 2ab. Bring the 2ab here. So you can write a square plus b square as a plus b whole square minus 2ab. We have a square plus b square here. I'm going to write it as a plus b whole square minus 2ab. Why we are doing this? So that we can sub in these values here. Now just sub in the value, that's all. Alpha beta is 3. 3 square plus 6 square minus 2 times 3 plus 1. 3 square is 9, 6 square is 36, 45, 46 minus 6 is 40. That's all. It's a 4-mark question. Let's move on to part B now. Find the quadratic equation which has these two roots. Okay. We need to find the sum of the roots first. Alpha over alpha square plus 1 plus beta over beta square plus 1. Combine it to a single fraction by cross multiplying and multiplying these two. So you're going to get alpha times beta square plus 1, beta times alpha square plus 1, everything divided by alpha square plus 1 times beta square plus 1. Open the bracket on top and at the bottom, but at the bottom here, right, we can just simply use the value of 40. You don't need to write any steps here. So it's going to be on top alpha beta square plus alpha beta alpha square plus beta divided by 40. Take alpha beta as a common factor from these two, so we'll be having alpha plus beta, and then these two terms are alpha plus beta also divided by 40. Now use the value of alpha plus beta from here, 6 and 3. So it's going to be 3 times 6 plus 6 divided by 40. 24 over 40. 24 over 40 is 3 over 5. That's the sum of the roots. Now we need to find the product of the roots and then we write the quadratic equation. Now let's write the product now. Product is simply we need to find the multiplication of these two. Alpha beta divided by alpha squared plus 1 times beta squared plus 1. Value of alpha beta is 3. We know this value from part A, it's 40. Now we can straight away write the equation as x square minus sum of the roots. We calculated the sum of the roots as 3 over 5x plus the product of the roots is equal to 0, but the question clearly says the coefficients PQR are integers. So multiply throughout by 40 to get rid of these fractions. So you're going to get 40x square, 8 5s are 40, 8 3s are minus 24x plus 3 is equal to 0. That's all.